Okay, today we'll discuss about the Snowflake architecture. It will be, complete theory class only for today. And later, like a few guys have issues in taking trial version, right? So we'll just give a overview how to take a trial version of the Snowflake account. So coming to the architecture, so Snowflake is analytical data warehouse. Like from the first class onwards, I'm saying it's an analytical data warehouse, which is provided as a software as a service. Like we do have many technologies, tools, like which works as a platform as a service. Like this, I mean, we have to install that particular software and configure, maintain. Everything needs to be done at from the user end. So here Snowflake is not like not that kind. It's a software as a service. So it's just a built-in platform. Already a platform is well developed, and they are just giving us as a software. So we ideally know how to connect to Snowflake, right? It's just a browser based, nothing to install, no need to configure anything, just giving your information and entering into the Snowflake data warehouse. There you can create your databases, schemas, tables, whatever you want, you can create in this. So it's a well developed, already developed platform given as a service. So that's the reason we will call it as a software as a service, SaaS. Snowflake runs completely on cloud infrastructure. There is no on-premises data warehouse maintenance. It's purely cloud data warehouse only. So our Snowflake can host in AWS, Amazon Web Services, Microsoft Azure, and GCP, Google Cloud Platform. So only on these three clouds it will run. And as I'm saying, it's an analytical data warehouse. That means only storage can be done. No, Snowflake can do a data storage. That means whatever the 10 years, 20 years, 30 years of data, if you want, just store it, not to do any DML operations or processing of the data. Just you can store it as it is. And you, if you want to do data processing, like if you want to do some analytics, you want to join with the other tables, you can do that also, data processing. And we will get all the solutions very fastly, because we have a elasticity of using the compute resources. Whenever you have a huge demand, you can increase your compute resources, then automatically you will get your solutions very faster. So faster, easier to use, and far more flexible than traditional data warehouse offerings. So currently whatever the in other traditional data warehouses, to increase or your compute resources, then it needs like a manual intervention, and it needs some time to increase. So but here in Snowflake, it is not like that. It can just increase or decrease with our just in a few seconds. Now coming to the architecture, Snowflake have three layers basically: database storage layer, query processing layer, cloud services layer. So any data warehouse, we will say two generic models are there: shared disk architecture, shared nothing architecture. We can say like any data warehouse, whether is it a shared disk architecture or shared nothing architecture. So we will just generalize our data warehouse. But Snowflake is a hybrid. It follows the shared disk architecture methodology and also shared nothing methodology also. We'll see what is shared disk and shared nothing, and how Snowflake fits into both. We'll see. So just a big representation of the architecture diagram. So database, usually people will start from cloud services layer. Like first layer will be cloud services layer, then query processing, then database storage. This is like when a query executed, the follow order of the flow. But when we talk about any storage of the data or processing of the data, like database storage layer first, all the data will get stored in this layer. And query processing layer, here if you want to do any computation, computation is nothing but DML or DQL if you want to perform, then here the query processing layer will involve. And once the your output has been generated from query processing layer, it will be delivered by the cloud services layer. So we'll see in detail what are the unique properties available for each layer. So first of all, we'll see shared disk architecture. in the name itself we can understand one particular storage can be shared with all the other compute resources. So first of all, what is storage, what is computer resources, we'll just talk about this. So suppose if when we are buying a laptop, what we will check, we'll check the storage configuration, how much hard disk is there, like is it 1 GB or 1 TB, SSD this much is there. So this is related to the storage, whatever you check the configure. So this is about storage, how many files you can store in your laptop, that is the storage. And again, what you again few things what you'll check, you'll check the CPU rate, RAM, processing speed, all this. What with the help of all these criterias, what we will do, we will see like what about performance, like from one file to other file, the navigation speed, or if you open one file and something you update and close it, how much time it takes. So we need everything in a faster manner. Suppose you have opened 10 applications in a laptop, then all should work in a, all should give a proper result, faster result for us. Like it should not delay, like opening the application and entering something into it. So if we see that, we will say like my processor speed is less or my CPU rate is less, so it's having the performance issue. So here also the same thing. To store your data, we do have database storage layer. And to process your data, that means like to insert the data, to update the data, to delete the data, so we do require compute resources for performing all this, which is nothing but CPU, memory, RAM, all these are called as compute resources to perform your activity. So here if we just come to the shared disk architecture, we have disk storage in the picture. If we just see, we do have three disk storages, all are shared with all the compute resources. So I have cluster node 1, cluster node 2, cluster node 3, cluster node 4. So first disk storage 1 is sharing the data to all the compute resources. Disk storage 2 also sharing the data to all the compute resources. The storage 3 also sharing the data to all the compute resources. That's the reason we will call these architecture as a shared disk architecture. Multiple cluster nodes having CPU and memory but no data storage. Like it's a anyway, storage and computation will be different, but whenever the data is sharing with all the clusters or compute nodes, then we will call it as a shared disk architecture. So what is the advantage here? Suppose if one disk storage has been failed, it has the information in from the other disk storages also, and it can be accessed by all the compute nodes. So that's the reason there won't be any delay in the data or any disturbance in the data. But when come to the disadvantages, like same data is getting replicated in three disk storages, and we have to pay for that also. So this is the disadvantage. And coming to the shared nothing architecture, so as the name itself suggesting, here nothing is shared, everything is individual. So if we just see the diagram, the disk storage one is having only cluster node 1, it shares the data only to the cluster node 1. Storage 2 also shares to only cluster node 2. Likewise, disk storage 4 also shares only to cluster node 4. So there is no interaction between the clusters, each other. So here the advantage is like cost wise we will be benefited, because the disk storage is sharing only with one compute node and it is not sharing with the others, so cost wise it is beneficial. But the disadvantage is, like if there is any failure, then we cannot retrieve the data. We cannot, I cannot say we cannot, but we can retrieve the data, but with little difficulty, because that's data is not getting replicated with the other disk storage or the compute node. So that's the reason these are the advantages between shared disk and shared nothing architecture. So these are the two generic architectures in the market. So ours, I am saying, Snowflake is a hybrid of both shared disk and shared nothing. We'll see how it works. So first we'll talk about the database storage layer. So what we'll do, like we just create a table. Always the data in any data warehouse will be obtained will be available only in tables, not in databases, not in schemas, not in pipe stages, anything. These all are the intermediates to get the data loaded into the table. So in your database storage layer also, you will be having tables only. So when you load the data, insert the data into the table, automatically the data goes into the database storage layer. But we, after going into the database storage layer, it does some activities. So whatever the data you have loaded, first come first serve. Whatever the data, suppose you have loaded 1,000 record, first record it will enter, second, third, fourth, likewise 1,000. So once you load the data into the table, it reorganizes the data in its internal optimized manner. So internal optimized manner in the sense, at the back end in a table, micro partitions will be there. So if you have loaded 1,000 records, based on the data volume, it just segregates 1,000 records into few micro partitions. Just consider 4 micro partitions. So in micro partition 1, out of 1,000 records, 300 records may be stored, and in micro partition 2, 200, 3 something, 4 out of 1,000, based on the data volume, data size, it will just store the data in its internal optimized manner. So for retrieval of the data, what is the easy method, it will just store in that format. And then after just segregating the micro partitions, then it do compressions, it applies the compression algorithms based on the data and do the compression on the data level. And all the data, whatever micro partitions or compression, everything stores in the form of columnar format. So the data in a Snowflake stores in columnar format, not in row level. So in other databases, the data will be segregated, even partition, we can say, partition with the help of rows, I mean in the form of rows. But here in Snowflake, it is columnar format. So it manages all aspects of data stored, like this particular layer stores the organization file size. So we'll say micro partition is a file. So file size, structure, compression, metadata, statistics. So statistics in the sense, every micro partition will have few information related to that micro partition. How many records are there in the micro partition, and what is the minimum and maximum value range for each column, how many distinct values are there, how many null values are there. So this type of information, metadata and statistics also, will be stored in a database storage layer. And all the things like whatever we are discussing, micro partition, compression algorithm, columnar fashion, metadata, can we see all these objects? No, we cannot see. Even like we cannot see a table also, even we cannot see database storage layer. This is completely purely we need to assume. In this database storage layer, whatever we are seeing, these are not directly visible to any customers. It just can be accessed through SQL query operations. Suppose if you want to insert the data, just insert into table name. If you want to retrieve the data, select star from. We are not able to see, okay, table looks like in a cylindrical format, these many micro partitions, 10 files are there. Nothing we can see, like we can just see the count of the micro partitions. I'm not saying that, but physically we cannot see anything. And here the data is get shared, I mean shared by compute layer. Okay, we'll just discuss that topic. So up to here, any doubts? Database storage layer. Okay. So next layer is compute layer or query processing layer, we will call. So here it provides compute resources. That's the reason we will call it as a compute layer. Or with the help of compute resources, what we will do? We will do query processing. So query processing is nothing but DML, DQL operations. So that's the reason this layer may be or is called as query processing layer. So compute layer is different from storage layer. So when we see the architecture also, they are not coupled or not attached. The database storage layer will be different and query processing layer will be different. So compute layer is different from storage layer. Here in the compute layer, like we need to provide compute resources to perform the actions. To perform the DML and DQL actions, we do require RAM, temporary memory, and CPU, all this we need to provide. So for that reason we are creating an object called virtual warehouse. So here this particular warehouse is not related to our data warehouse or storage warehouse, but it's just like it is saying like I am storing my compute resources. That's the word given in Snowflake. It's a just purely Snowflake object, virtual warehouse. As we cannot see this, that the name mentioned as it's a virtual warehouse. In this virtual warehouse, like we will get the compute resources to perform a query operations. So how to create a virtual warehouse? Yes, we have a separate topic, like tomorrow not tomorrow, Monday we'll discuss how to create a virtual warehouse. Like we do have many sizes of warehouses. According to your usage, you have to select like which size of warehouse, which size of compute resources do you require. And we do have different modes: auto scale mode, maximized mode, and policies: standard, economy, policy, auto resume, auto suspension. Everything will be available in this virtual warehouse. So we'll see I mean at the time of warehouse class, when a query is executed, it retrieves the data from a database storage layer. I mean, we have already seen while creating the objects, we don't require a warehouse. We already seen. But when I am performing insert or select queries, it is saying no active warehouse is available. Use warehouse, any warehouse. So at that time, I have just set it my context to warehouse and ran the query. The query has been run, because when you are performing any DML and DQL operations, it provides compute resources for that query, and it goes to the database storage layer and gets the information from the database storage layer. Here each virtual warehouse is a massive parallel progressive compute cluster having multiple cluster nodes. So we do have a single cluster warehouse and multi-cluster warehouse. So in the single cluster warehouse, you will get only a single set of compute resources. If your queries are like very small, I mean, you need only one cluster of compute resources, then you can go for a single cluster. If you do require like having multiple clusters, multiple clusters are required for your data, then we will go for this multiple cluster warehouses. Each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. So this is the main point we need to understand here. Each virtual warehouse, like each virtual warehouse means, so can we create multiple warehouses in our Snowflake? Yes, we can create n number of virtual warehouses. There is no limitation like we have to create only 3 virtual warehouses, 4 virtual warehouses. Okay, fine, we can create n number of virtual warehouses. What is the purpose of creating n number of virtual warehouses? Suppose, just consider in a real time project, we will have separate teams. Development team will be there, testing team will be there, QA team will be there, production team will be there. In the development team, like we will have users, multiple users will be there. Suppose, just consider 10 users are there and they are performing development activities. So if they are performing development activities, if they are performing development activities by 10 persons, by 10 persons, then what we have to do, like we need high compute resources for these 10 people, because they might perform a huge number of data retrieval or huge number of update statements they can run. So for them, a huge set of compute resources are required. For testing team, so they also perform the testing, but not with the huge data. So they may require only medium set of compute resources, not huge number of compute resources. And for QA team, so QA team, just it's a quality analyst team, like where they'll perform like whether the quality of the data is good, or are they expecting whatever the user asked. So these type of things they will do. So for them also, like medium set of, or very small set of compute resources are required. And if we just go to the production team, so for production team, we do require huge number of compute resources, because whatever we have done in development activity, the same thing the production team also will do, because it's a real time project, every day it will be running. So they also do require huge compute resources. So that's the reason, what I will do in my organization, I'll just create 4 virtual warehouses. For development team, they do require huge compute resources, so I'll create a virtual warehouse with L size. And for testing team, they do require medium compute resources, so I'll go with the medium size. And for QA team, I'll go with the small size of warehouse. And for production team, I'll go with the L size of compute virtual warehouse. That means I'm just segregating the compute resources according to the usage. So in this way, we will get a chance to create a number of warehouses, virtual warehouses, and these virtual warehouses cannot be shared with each other. So here, like suppose development team virtual warehouse is there, which is nothing but dev warehouse, and the testing warehouse is there, testing warehouse. So what happened, development warehouse is full busy, and testing warehouse is still not full busy, it has still left with a few compute resources. So development team, can they go and ask the, because testing team warehouse compute resources are still free, can I use that warehouse compute resources as my test development warehouse is busy? No, we cannot do. Whatever the compute resources allocated to development warehouse needs to be used only for that team. And testing warehouse, whoever are authorized, and those compute resources, whether other warehouses are busy not busy, they do require urgently, they will not provide, testing team will not, testing warehouse will not share their compute resources with the other virtual warehouses. So which is nothing but shared nothing architecture. Here they perform their own individual duties. If the warehouse compute resources are free also, they'll not share with others. So we can understand this query processing layer or compute layer is acting as a shared nothing architecture. If we just go back to the storage layer, here one particular data is can be, like suppose we have some table called table employee. This table employee can be accessed by the development team using dev warehouse. This table, that same table employee can be accessed by the QA team using QA warehouse, production team by using production warehouse. Nothing but one particular data set is shared between multiple compute resources. So database storage layer is acting as a shared disk architecture. So just to fit the separate layers, shared disk architecture, database storage layer, and shared nothing architecture is the compute layer. So we will say it like Snowflake is a hybrid of both shared disk and shared nothing architecture. As there is no dependency between each warehouses, there won't there won't be any impact on the performance of other virtual warehouses. So there is no dependency between each other, so we cannot calculate the performance overall like all warehouses. It's individual, you have to calculate the performance. It is up to development warehouse, it is up to testing warehouse, production warehouse, like that differently. So here, this compute layer, storage layer, like how it fits into shared disk architecture and shared nothing architecture. Is it okay up to here? Any doubts?
One question.
Mm,
So this all everything happens in cloud, right?
yes.
Okay. And when you say this virtual warehouse is created, so
Mm,
like say for example, you're running a report, okay?
mm,
So it has to fetch the data from the storage layer,
mm,
and a virtual warehouse is created, and it fetches and gives you the output in the required
mm,
format, like whatever you want.
mm.
Now, once that is done, will this virtual warehouse still exist or will it disappear?
Yeah, that again, when we design a virtual warehouse, we have a timer called auto suspend and auto resume. So if you just say like this much idle time, if I want like
Hmm.
if I am seeing continuous 5 minutes of idle time, just suspend my warehouse. Or if you don't want, never you should suspend your warehouse, just give it as a like never. uh, so this thing, like if you keep, if your query has been ran for 2 minutes and you also kept like a idle time of 3 minutes, then what happens, it will check next 3 minutes. So after 5 minutes the warehouse will get suspended. Until that, if you are still running some queries, then it will not get suspended, still that warehouse will exist.
So that that suspension will be there as a auto or It is going to be need to restart or reuse kind of
No,
thing.
we can do two methods. Auto is there and forceful suspension also can be done.
Forceful suspension.
Anything.
No, no, not forceful suspension. I'm talking about
Mm,
uh, if it is already been suspended for 3 days. Example, take an example is suspended
mm,
for
mm,
3 days.
mm,
Then once the new query has been used by using that
mm,
warehouse, so
mm.
the warehouse will be
Yeah,
automatically
that
open.
that is the same thing. Like while designing a virtual warehouse, if you enable the
Okay,
auto
you're going to
resume
design that.
option,
Okay.
yeah, if you enable the auto resume option, automatically if you just retrieve the data or perform any DML query, it gets automatically up. Otherwise, like if you don't select the auto resume option, then you have to do forceful resume by
Yeah,
using the
great.
query.
Okay, thank you.
Okay, one more question. Like, say, for
Mm,
example, you're running an MTD report, month to date.
uh,
So that report would be executed on daily basis by the business.
uh,
Like, say, for
yes.
example, if you're running report today, your data should be captured from 1st of February to like 16th of February or so.
Uh,
And tomorrow,
uh,
if you run the report, it should capture the data from 1st of February to 17th of February or 18th. Okay.
okay.
Now, my question is like, once you run the report, will the data will be cached in the virtual warehouse, the
Yeah,
previous data?
no, no. See, previous data will not get cached. The caching part is there with the virtual warehouse, but the lifespan is only until the warehouse suspension. So, if your warehouse gets suspended within 2 minutes or 2 days, until that days, like your caching data will be there. But once your virtual warehouse gets suspended, you will not get the data.
Okay, it doesn't hold any data physically,
Uh,
you mean to say.
yeah, physically it doesn't hold. It will hold, but
Okay.
up to the warehouse suspension.
Okay. So, I mean, like in general, businesses use the report on daily basis, right? So
Mm,
that reports can be used like at any point of time in a day, like Monday. I mean, like no, I mean since morning, afternoon, or any end of the business day, like.
mm.
So in the meantime, maybe that report uh, could take a time of around like 2 or 3 minutes for getting the data. But in the meantime, the computing resources can stay idle if not suspended, right? So still the catch part will be existing if it is
Okay.
not suspended.
Idle or suspension both are same. Like if it
Both are
encounters
same.
this much yeah, if it encounters this much idle time, the suspension will happen. So just the same thing, 2 minutes your query ran, you just kept like 3 minutes of idle time. In these 3 minutes again, like after 2.5 minutes, like 4.5 minutes, you start running the select query on the same thing, you will get the data from the cache itself. Okay. After
Mhm.
completion of 3 minutes, if you are running again select query, then it goes and gets the from the database storage layer.
Okay, so one more thing, when Snowflake charges
Hmm.
the costing based on the data retrieval from the cloud. So
Yes.
like if you access the same report in the morning
Hmm.
and in the evening as well, so will it be charged twice?
Again, like we have a concept of materialized view. If you are thinking like you want to retrieve the same report, if your underlying tables are not getting changed, there is no frequency of the thing, you can create a materialized view. In that, it just stores the pre-computed results. Whatever you have ran in the morning, it will just store that data. And when you are running in the evening, if there is no change in your underlying tables, whatever you are running, then you will get the data from the cache itself, not from the database storage layer. So at that time, you will get the less cost when compared going to the storage layer and getting the data.
Okay, thank you.
Okay, anyway, we are discussing about the cost, so we have to discuss about the cost in Snowflake. So we are having the layers also differently. Storage layer is different, compute layer is different. So the charges also, 1 minute. Please. Sorry, I'm back now. So as we are discussing about this, we need to discuss about the cost also between storage layer and compute layer. So we do have three layers in Snowflake. Storage layer cost is different, compute layer cost is different, and cloud services layer is free of cost. Like for as we are using both the storage and compute layer, cloud services layer cost is free. I mean there is no cost on the cloud services layer. So how this charges part will be different for the storage layer and compute layer. So in the storage layer we will just store the data. So that means like whatever the data stored on an average per month, that charge we need to pay for Snowflake, only storage cost average of per month. And compute layer, so how many virtual warehouses you are running, how much time you are running. So for it's if you run for 30 seconds, now first minute it will be 1 minute charge, next 30 seconds you have to pay only for 30 seconds, 20 seconds if you are running your warehouse, even your warehouse is in active state but you are using the compute resources for 20 seconds, we have to pay only for 20 seconds of charging. Or if you have used complete warehouse for 120 seconds, then you have to pay for 120 seconds. So as I'm mentioning, like here seconds, not in the form of minutes. So in Snowflake the charges will be paid per second billing. So how many seconds you have consumed for warehouse, again like the size of warehouse, small is there, medium is there. So for small it will be this much credits. So here the measurement of calculation will be in the form of credits. So for if you are using small warehouse for 2 seconds, then these many credits will be consumed. If it is you are using medium warehouse for the same 2 seconds, then these many credits will be consumed. So based on credits the charges will be applied. So this credits is just a measurement like a cages, liters will say. So this here also credits are the measurement. These credits will be charged, I mean will be converted to amount based on which cloud you have selected, which region you have selected, and which edition you have selected. So based on three criteria it will be differed from region to region, cloud to cloud. Suppose maybe in central India Pune region it may be 2.3 per 3 into 1 credit. So if it goes to the USA it may be $2.45 into 1 credit. So based on the these three parameters the costing part will be changed. But that we will see in the warehouse class how it charges, because we are discussing about the small, extra small, all the warehouse sizes. So I'll explain in detail how that costing part will be. But here the costing for storage is different and compute layer is different. Storage only whatever you are storing on an average per month, how much size you are storing, that you have to pay. In the compute layer it is pay per second billing for whatever warehouse you have used, how much time you have used for that seconds you have to pay for the compute layer. And anyway cloud services layer it's a zero cost, there is no charge on the cloud services layer. So now coming to the cloud services layer, final layer, this is the like we will call it as a brain of the Snowflake. So all in the storage layer just storing part, query processing layer assigning compute resources to perform that action, just that's it. Like in the cloud services all the real time scenarios, in the sense the extra activities which are related to control a data warehouse will be happened in the cloud services layer. So all the activities like authentication, security, metadata management of the data, and query optimizer can be handled. So first of all we'll see authentication. So when I logs into the Snowflake, what happens, it asks me I mean I need to provide my URL in the browser. Once it is done it will open a login page. So just your username and password. So this who will be validated, our cloud services layer will gets validated. First what it will validate, for this URL whether this particular user is there or not. Whether if this user is there, then the password by whatever entered is matching for the user or not. All these authentications will be done by cloud services layer only. So this is when a login request is placed, it has to go to through this layer only. This layer will validates all the checks. Once everything is correct for this account, this user is available. For this user, this password is the correct. Then only we will enter into our Snowflake site. Otherwise, we will not enter into, like it say invalid username or password or incorrect username or password. We will get the error. So these type of checks will be done by the cloud services layer. And other type of authentication, I'll say. So when we want to retrieve the data from a table, select star from table employee I have just given. So this query, first it will go to the cloud services layer. When I submit the query from the screen, this query will be going to the cloud services layer. In this cloud services layer, it will just analyzes the query. Before that, it will just analyzes whether this particular query syntactically correct or not. Select star from table instead of, I have given select from table instead of star or columns, then syntactical error. So it has to validate syntactical things first. Once the syntactical things are validated, checks are validated, all everything passed, then it will go to the compilation thing, whether this object is available or not in our data warehouse or not. Once this object is available, if object is not available, it will throw error. If object is available, it has to check whoever the user running currently with which role, whether they have privileges to select the data, to retrieve the data from this database schema table or not. If yes, then it will analyzes what type of query. Is it a metadata query, or is it a complete retrieval of the data query, or this query has been ran for the second time so that I can use the cache data. So this type of analysis will be done by the cloud services layer. So accordingly, what type of analysis it has been validated. So if it thinks, okay, this query has been ran for the first time, there is no cache data, so I need to give this query to the virtual warehouse, that nothing but compute layer. So it will just pass this query to the compute layer and says, okay, this query has been came and we do require some few compute resources from your end, so that with the help of your compute resources, it go to the database storage layer and gets the information from database storage layer, and again comes to the virtual warehouse compute layer, and comes through compute layer, it again comes to the cloud services layer and gets the information on the screen as a result. So all these steps, like the major entry point is cloud services layer and metadata required. So in the cloud services layer, along with the information, we do have micro partitions metadata also. Wherever we do have micro partitions in database storage layer at the tables data load, but the same information, respective information of metadata, will be available in a cloud services layer also. Suppose if you just want count of star from the table, so it's a metadata, then it no need to go to the database storage layer and count the number of records, because cloud services layer itself maintaining the metadata of each table, of each column, it is maintaining, so it will get the information from the cloud services layer only. So this type of information, if I am getting very fastly, then my performance will be increased. So this type of activities will be maintained by cloud services layer. So that's the reason we will call it as a brain of Snowflake. And the charging part, it's a free of cost, as we are using both storage layer and query processing layer. So this is about cloud services layer. Any doubts?
One more question over here.
Hmm.
You said if that same query has been accessed again, it will bring the data from the materialized views, right?
Yes.
Yeah. So now say for example, the user has requested data initially, select employee ID, employee name from the table. It brings data from the database storage layer initially for the first time,
Mm.
and that data gets sits in the materialized view, as you said. Now, say for
The
example, and yeah,
mm, that data does not sit in the materialized view. Whatever the query you want to run frequently, you'll create
mm,
a materialized view on top of your query.
okay, okay. So
Yeah.
okay, you're saving the query in the materialized view.
Yes.
Okay.
I understood your question. Suppose if I change the query, then will it gets the from the cache or not? Is it the same question?
Yeah, now I want to add one more field along with the ID and name. I am changing
Hmm.
the query, right, definition. So will
Okay,
it access?
just yeah, just ignore the materialized view. So your query is first time you have run select employee id employee name from table, it will go directly from the database storage layer and gets the information. So while getting the
Yes.
information, it will store cache the data in virtual warehouse layer and also in the cloud services layer also. So we do have a
Mm-hmm.
caching topic. So we do have two caches, virtual warehouse cache, which is nothing but local disk IO cache, and in the cloud services layer we do have result cache. So there also it will store. So if you are running for the second time within a 24 hours span, then you if you are running the same query within 24 hours span, then what you'll get the data from the cloud services layer result cache, because result cache lifespan is 24 hours. If you are
Okay.
I mean, if you are just changing your query for adding the extra column or giving extra filter, then it will not get the data from the result cache. So result cache property, not only result cache, local disk IO also. So the property is, you should not change the query. The query should be as is to get the data from the cache, and the underlying table should not change. When you ran for the first time and for the second time, the underlying table's data should not change. If these two criteria are passed, then you will get data from any of the cache. If these two criteria are not passed, then again it will go to the database storage layer and gets the information.
Okay. So even if it's an addition of single field as well, like,
Yes, exactly. So earlier you have ran select star from table. Now if you just say select employee ID comma employee name, out of star I am asking only two columns, even though it will
yes,
go to the database storage layer.
database. Okay.
Yeah. Okay. Any
One
others
more
have?
question, like
Hmm.
metadata is something you said, like the count of the records, right? Generally, metadata definition is data about data, right?
Yes, again, like data about data, right? Whatever the data stored in a table, about that data, like how many records are there in a table, what is the minimum and maximum value for each column, distinct
Okay.
values, null values. So these are the metadata.
Okay. Thanks.
Okay. So ideally, like any data warehouse in a real-time projects, we do have these environments: development, user acceptance testing, UAT environment, production. So some may be like between development, UAT, SIT environment also there. So we may create or not. That is not mandatory, but majorly these will be available. So whatever we do development activities, that will be available in development environment. Once you think like okay, my data is I mean proper, like whatever the user requested, it is looking same, then you will promote all the changes. You will do code deployment of all the code data to UAT environment. Then you will ask the user who has given request to you, that person will validate the data. Once everything is fine, it will be moved to production. You will get the sign off. Then you will move that to production. If the user says like some has given a feedback to rework on that, like this part I am not okay, this is not showing correct data, then what happens, you need to go for a development environment, again change accordingly whatever the feedback we received. Then once you are confident like I have completed my feedback, then you move again the changes to UAT environment. The user validates. If everything is well, he or she provides the sign up, and it needs to move to production. This is the thing, like process in real time projects whatever it happens. So while doing our training also, we'll do the same thing, like we will create development environment, UAT, production in a single Snowflake account. We will see how to create all these things. And coming to the data flow, so I am
Yeah, one
yeah.
question, Lahari.
Mm,
Uh,
yeah.
so I mean, like, when in the landscape, it's like three different servers, right? So development, testing, and production. So will all they be available under that same URL or three different URLs? Like
Here, see, it can be in a real-time projects. It can be
yeah,
either
in
or
real
that.
time.
Yeah, in real time, few people will maintain under one account, one URL. They'll maintain three environments in the form of databases. So development database, production database, UAT database. They'll just segregate with the help of databases. And few people, they'll create separate accounts, separate URLs for one URL, nothing but one account for development, one account for UAT, one account for production. So at that time, there won't be differentiated with the databases. It will be differentiated with the accounts. So either or case, like it can be.
Okay.
Okay, and the data flow, according whatever I will just explain, it will be differentiated with the three different layers. So pre-stage, which is nothing but a landing zone for the data. You may get the data from ETL team, like from traditional databases or data warehouses, or you may get files from the like any other customer places in a cloud. You want to look up that data, or some ad hoc files you will get like yearly ones or quarterly ones. You have to just process it. No need to process daily. Just keep it up, keep it with you, and store the data in your data warehouse. So for that reason, like I have just saying, like pre-stage will be a landing zone. You may get data from different sources. That will be a landing zone. And again, this data will be moved to the stage layer. So where here few tables, like majority of the tables are one to one between pre-stage to stage, and few tables are having incremental load, as we do have a transactional data every day, invoices. This kind of data we cannot do everyday truncate and load, so we'll do incremental load. So that will be available in the stage layer. This is the second layer of the database tables. And final layer is DW. So by using the stage layer source tables, we will generate a fruitful result according to the customer, and will be given this layer tables information to the reporting team to generate the reports. So we will see like how to work with the pre-stage, stage, DW, just landing zone, like that, similar thing.
So where does the transformation comes over here? Like in which stage does
DW,
it come?
DW,
DW.
yeah,
Okay.
finally. Okay, so this is the I mean whatever we are going to be discussed in the training completely, these three layers. Yeah, any others have doubts? Who needs the class of taking trial version of Snowflake? Can please someone raise or unmute yourself and explain me? I mean, someone asked yesterday, but I'm not sure.
Yeah, can you drop that URL please, like for signing up?
Okay. Uh, yeah. Having issues with the screen share? I mean, I'm just seeing messages now. Okay. So no one wants like a trial version class, or anyone wants? Like I'll just explain, or I'll share the document also with you people. No issues. Then if we don't have anything, like we'll just meet on Monday and see the topic of virtual warehouses. By that time, just have your Snowflake trial version ready so that you can also start on the same day how to take a virtual warehouse, create a virtual warehouse. Okay.
Yeah, Lahari, in interest of time, actually, I missed it. First 2 to 3 slides. Can you go through that, please? Anyway,
Okay.
I'll not take much, just 6 minutes of time.
No, which slides you have
Yeah,
missed? From
two,
where
three,
you
four,
have listened?
2, 3, 4.
Okay, so first, like Snowflake is an analytical data warehouse. We already knew that it will store the historical information for analytics purpose, and it is a software as a service. So software as a service in the sense, already a well built platform has been designed and given to us as a service. So if we just open Snowflake also, just it will be, we will just connect to through browser. Like suppose if you are opening an app, what you will do, you will just open that app with your username and password. In the similar way, you will open it and create your databases, create your data warehouse itself. So that's the reason it is called as a software as a service. So if we go to the other traditional databases, they may be platform as a service. So we need to install the tool. Suppose if it is Joom, I have to install the Joom, and if there are any patches needs to be there, I have to do upgradations, I have to do everything needs to be done. So this is platform as a service, but Snowflake is just a built-in service which is already well developed and given it as a service for us. And Snowflake only runs on cloud infrastructure. It is not on premises data warehouse. So we will not store any physical servers or anything related to CPU, hard disk, nothing in a one particular place. It is everything on a cloud infrastructure. And as we are seeing, the analytical data warehouse, it stores only the data? No, it stores the data, few years of data, historical years of data, and also we can do data processing also. Data processing in the sense, if you just want to retrieve the data of some 2002 year of south region, then you can retrieve the data from the whatever the data you have stored in your Snowflake. That can also be done. And analytical solutions, so as it is like we have a option of elasticity of increasing the compute resources and decreasing the compute resources at any point of time, which is nothing but a virtual warehouse. So we can get the data in a faster manner, easier to use, like increasing or decreasing can happen within seconds, easier and far more flexible than traditional data warehouse offerings. So currently, like if we just go for a traditional data warehouse to increase our compute resources or decrease or to go back the data, time travel, data sharing, all these not have available in traditional data warehouses, but here we do have in Snowflake. And coming to the architecture, we do have three layers: database storage layer, query processing layer, and cloud services layer. So in this I mean, any data warehouse, we will say in the market two generical architectures are there: shared disk architecture, shared nothing architecture. So we'll say our data warehouse, which architecture it fits, either in a shared disk or shared nothing. But our Snowflake fits in both shared disk and shared nothing. So we have seen already, as database storage layer shares the data to all the virtual warehouses. There is no limitation on that. So that's the reason database storage layer itself called as a shared disk architecture. And virtual warehouse layer, that is compute layer. Here the virtual warehouses whatever we have created, these will not be shared. The compute resources will not be shared by other virtual warehouse. So that's the reason we will call only this layer as a shared nothing architecture. So Snowflake is a hybrid of both shared disk and shared nothing architectures. Okay, so the fourth slide is just a
No,
representation of the
one, one,
architecture.
one question on the shared and non-shared part.
Mhm.
See, as Snowflake is being a hybrid of shared, and so what this sharing? So they will give you only certain space to execute the things, or how the shading and non-shading is being identified for the user.
See, the same thing. Suppose I have table employee, development warehouse is there, development team, production team is there, testing team is there. All these
Yeah.
three teams can access the table employee. So which is nothing but one table
Yeah.
can be accessed by multiple compute resources. Multiple
Correct.
compute resources, nothing but multiple warehouses. Multiple warehouses, nothing but multiple teams. So that's the reason
Correct.
we will call this database storage layer as shared disk architecture.
Okay.
If we go for the virtual warehouse layer, which is nothing but compute layer, so if development team virtual warehouse is very busy and they do require extra compute resources, so they can go and ask to the testing team, will the testing team warehouse will provide? No, because they are not shareable, they are very independent to each other. If you have free, just use it, otherwise I will not give you, and I will not ask you. So that's the reason just query processing layer is shared nothing architecture.
Oh, got it. Got it. Now I got it. No, no, what I got it. Okay. Now I got it.
Okay.
Thank you. Thank you very much.
Okay. Okay. Okay, guys. Any others have doubt?
So, one final question. So, the cloud
Mm.
services and database storage will be a shared architecture, and query processing will be a non-shared one.
Cloud services layer, we cannot say anything. Shared disk or not shared nothing. But only
Okay.
database storage layer will be shared disk, and cloud services layer is, sorry, compute layer is shared nothing architecture.
Shared nothing else. Okay. Thanks.
So in the cloud service, you have optimizer, right?
Hmm.
So is, does that takes care of the computing processes warehouses? Maybe?
No, no, just this optimizer will use the metadata information and just query pruning, like it will give the faster plan to execute. That's it.
Okay. Performance improvement, you mean?
Yes, exactly.
Okay.
Okay, guys. If we don't have anything, like we'll see on Monday with a new topic. Thank you.
Thank
Yeah,
you.
sure. And but Larry, I was just checking. If you can able to prepare a small questionnaire or at least one or two questions or five questions on every day of the start of the yesterday's class, so that we can able to make out right. Is that possible? Or later you can try it out.
Uh, I mean, okay, we'll
No,
do
just
one. We'll have.
I'm just giving a suggestion to make sure that we everyone is there in sync with the class. You got it, right? What I'm
Okay.
saying?
Yes, yes,
Yeah,
exactly.
it's like a recap of what has done.
Yeah, it's a recap or kind of a knowledge check or whatever. Just
Mm.
small thing. Not now, in future, that will be very useful for everyone, I thought. Just a feedback.
Will this
Sure, sure.
PPT be yeah, sorry, will this PPT be shared?
Yes, I'll share.
Okay, thank you.
Thank you.